Thank you, and welcome everyone. My name is Nicholas Boucher. I'm a PhD candidate at the University of Cambridge, and I'm here to present some work that I did with Professor Ross Anderson titled Trojan Source, Invisible Vulnerabilities. And first, let's start with the highest order bit, which is to say that some vulnerabilities are invisible. I'm going to talk about a novel class of vulnerabilities that are quite interesting because they cannot be seen by humans when text is rendered. These are vulnerabilities that exist within the encoding of some source code file, and again, are not actually visible to humans when these source code files are rendered. So let's start nowhere else other than talking about Unicode, which is the text specification standard that has largely overtaken the world. Something like 97% of the world's most accessed 10 million websites are using it. The vast majority of modern operating systems use it for just about everything, as do programming languages and a variety of other things in the modern world. And let's look at some examples of Unicode. So let's start with just a simple string, ABC. And on the top of the screen, I'm going to show you a representation of how this string is encoded. And on the bottom of the screen, I'm going to show you how this string would be rendered to a human who is looking at a screen from a computer rendering this text. So with this basic example, it's quite clear. It's the same thing at the encoding level and at the rendering level. But let's make it a little bit more interesting. So I'm going to inject two different control characters, and these control characters will work together to reverse the direction of the text. So these are directionality override control characters, and it will take text which is logically encoded in the order ABC, and it will render that text as CBA, the reverse of the logical encoding. So kind of interesting. Maybe we can do something with this, maybe we can't. Let's make it a little bit more complicated. So it turns out that these control characters can be nested within each other, and that when you nest these control characters inside of each other, you can do more or less arbitrarily complex manipulations of how these strings are rendered. And to make this a little bit easier to visualize, I'll go ahead and put some boxes around these different entities to group them together. But what I want you to see here is that the logically encoded order of this string, ABC, DEF, is actually rendered as DEF, ABC. And my hope with these examples are that you can start to realize that you can do all sorts of different manipulations that can take some specific logically encoded order of characters and cause them to be represented in an entirely different order when those characters are rendered. So the logical question to ask from this is, can we do something evil with this within the context of source code? Could I use these capabilities of Unicode and other internationalized text specifications to subvert source code in some way to make some sort of adversarial modification to code? And what you're going to be thinking is, well, sure, that would be nice, but surely I can't just arbitrarily inject control characters into source code files. I mean, that would surely cause some sort of problem. And the answer is that is true. We need to stick to the syntax of whatever language we are using, and most languages aren't going to allow us to just arbitrarily inject characters, control or otherwise, into our code base. But let's talk for a minute about comments and string literals. These are concepts that exist in almost every language, and as it turns out, you can put just about anything you want within the context of a comment or a string literal in the vast majority of modern programming languages, and that includes control characters. So now we arrive at the crucial trick, which is that we can take the control characters that I've talked about, and we can inject them into comments and string literals within source code files. And in doing so, we adhere to the syntax requirements of that programming language, but we also allow ourselves to adversarially manipulate how the text of that source code is going to be rendered. So let's run through all of that again, and I'm going to call this our architecture here for a pattern of vulnerabilities. And that is to say, first we started with saying that control characters can override the direction that text is rendered. We can nest these control characters within each other, and we can use this to more or less arbitrarily modify the display order of tokens inside of source code, and that we can take these control characters and we can place them into comments and strings, and within that we can adhere to the syntax requirements of just about any language. And putting all of that together, we arrive at the conclusion that some evil program A can be effectively anagrammed into some benign program B. Or phrasing that differently, I can take some evil program and I can cause it to be rendered in such a way that it doesn't look evil. So let's go through some examples to make this a little bit more explicit. So let's start with a toy program in C that's intended to be very basic. I'm starting by setting some Boolean is admin to false, and then I'm checking to see if that Boolean is true. And if it is, I'm going to print the statement you are an admin. And strange syntax aside, which we'll get into in a minute, if you look at this, it should be relatively obvious as a human code reviewer that this program should do nothing. I'm setting a variable to false, and then I'm checking if it's true. It's not going to execute. But let's take a closer look at this strange line of code right here. And zooming in on it, I'm going to show you two different views. So first, I'm going to show you what the compiler sees. And now I'm going to show you what a human is going to see. And what you'll realize is that this is not actually a conditional statement, as it looked like on the previous slide. It's actually just one long comment. And inside of that comment, I'm injecting these directionality override control characters in a way that's causing that comment to be rendered as if it contained a conditional, which from the perspective of the compiler isn't actually there. And again, this is designed to be very obvious. It's designed to really jump out at you. You can be much more elegant in how you encode these things such that they don't look quite so strange from the perspective of someone who's looking at the code. But let's zoom out one more time and again see that this is what it's going to look like if you render this source code and look at it. But if you were to run it, what you're going to see is that perhaps contrary to your presumed initial expectations, it is going to print out that you are an admin despite that Boolean being explicitly set to false at the beginning of the program. So that's a basic example of what we're doing with this vulnerability pattern that we describe in the paper. And I'll put up here the different languages that we examined within our paper that we found to all be susceptible to this type of attack. And what we basically found is that every time we looked at another language, we found that we could conduct the exact same attack. If you're leveraging Unicode and if you support the concept of a comment or a string, well, I mean, you're probably going to be vulnerable to this pattern, this anti-pattern of attack. So we did have two CVEs that were issued. These CVEs were actually against the Unicode specification itself rather than against any particular language that we're talking about on the screen here. And the reason is that we wanted something that we could point to centrally, that we could say, look, this is actually an issue with the specification, saying that we should have had some sort of call out in the specification saying in the domain of programming language, because there's other domains that are explicitly called out within text specifications, there are additional security considerations around directionality override characters. But let's not go too far down that road. Let's actually talk about why this is more significant than any other vulnerability patterns that might come to mind. And that's particularly in the context of supply chain attacks. So supply chain attacks are this idea where you're trying to attack something that is upstream that might flow to downstream dependencies and potentially have a vulnerability that could affect the ecosystem broadly. And within the context of supply chain attacks, imagine that you have some open source component where you have lots of developers across the ecosystem that are making contributions. And well, if you're trying to prevent an adversary from injecting some malicious functionality into your cool open source package, your primary defense against that is code review, which is being conducted by humans who are typically looking at rendered text. And guess what? We just talked about a pattern where you can encode a vulnerability in a way that won't be displayed in rendered text. So that's why I think that you should worry about this vulnerability pattern and that it's reason for concern across the industry. Now, that being said, we went through a coordinated disclosure process. We spent 99 days talking with dozens of different organizations, and it resulted in a variety of patches across some pretty major pieces of software. This is not an exclusive list by any means, but I'll talk about a few of them that are up here. And let's start by talking about how mitigations can be applied within code repository systems such as GitHub. And what you'll see here is that if you look, there's actually explicit warning signs, and then perhaps more interestingly, there's explicit representations of these directionality control characters on lines 6 and 8 of the code that you're seeing up here. And if that wasn't clear enough to show a code reviewer that something strange is going on, there's now this giant warning banner that pops up at the top of GitHub. Again, this was in response to our coordinated disclosure process. But that's not the only place that a defense can be used. We can also have defenses within the context of code editors. So here, VS Code is a pretty popular code editor that has also adopted some mitigations following our coordinated disclosure. In this case, they are also explicitly representing directionality control characters within their development environment. So another really strong defense mechanism against this. And let's talk about one more potential defense mechanism, and this is my personal favorite. This is defending within the context of compilers, and there's now multiple major compilers that have warnings or errors that are emitted when this anti-pattern is detected. But I'd like to highlight Rust because I think they did a really excellent job, at least if you look at the error message here, you'll see that they're really explicit about calling out, look, there are directionality control characters here, and it might cause the code to be displayed in a way that is entirely contradictory to what you would expect. So a really excellent way to defend against this particular attack pattern. So as I begin to wrap up here, I'll say that this paper also received a decent amount of media attention when we put it out. And one of the really cool things that I'll highlight was actually a response that came from Unicode itself. And what Unicode said is that they have ultimately convened a working group where they're going to put together a response that might result in updates to the specification or guidance or recommendations or even reference implementations to help downstream tooling, whether it's code editors or repositories or compilers to help provide some definitive guidance in protecting against attacks like the ones that I've described. So there's tons more that we could talk about. We could talk about attack generation, detection, variants, about the vulnerabilities themselves, how to defend. We could talk about the fact that we scanned the entirety of GitHub and we looked for examples of this in the wild, had some kind of interesting findings. We could talk about coordinated disclosure, industry response defense, but there's not time for any of that, so I will gladly point you to the paper. And I will also mention that the attacks that I've just described are not exclusive to source code. So I'll put a few other papers of recently published related work up here. So we published at Oakland last year something about using these same concepts to attack large language models and how they could be used to craft adversarial examples as inputs to these models. Later this year at RAID, we'll talk about how this can be used to subvert both indexing and retrieval within the context of search engines. And then we've got another paper at a CCS workshop last year talking in much more depth about coordinated disclosure. So there's a lot of information out there. If this is of interest to you, please do check out the website that we've put together. It contains all of this information, reference code examples in a whole bunch of different languages, and more. I will go ahead and stop there. Thank you all very much for your time. Thank you.